All right, this is 7-2. You can do this one on your own. You can either do it by hand or put it into Desmos, but you can go ahead and do this warm up on your own. Solving by graphing, remember you're looking for where the two lines intersect. We are continuing to find where they intersect today, but we are going to use substitution instead. So it's a new method, so we're not going to graph, but we're still looking for the point where the two lines intersect, and we're going to do that by substituting. So substitution is just a method to figure out where they intersect without actually having to graph them. So simple substitution we already know how to do. So this is just a super basic example to get us started. So it says find y when x is 3. So here's my equation, and I know 2, and then I know what x is. X is 3 minus 4 equals, we do not know y, that's what we're looking for. Okay, so they told us x was 3, so all I did was plug the 3 in for the x here. So then I just solve it. So 2 times 3 is 6, and 6 minus 4 gives me 2, so y is 2. Okay, that's substitution. You take something and you plug it in for something else, and that's what we're doing today. It's just going to look a little bit more complicated because you're going to have other variables that you're plugging in as well. So the steps is you're going to isolate one of the variables. Okay, today this first step will be done for you, but tomorrow it will not. So just keep that in mind. But we're going to isolate one of the variables and want to isolate the easiest one. So that'll happen more tomorrow. And then the second one is to substitute the answer into the other equation. Okay, so you use one of the equations to get the variable by itself, and then the other equation is the one you're substituting for. Then you solve for the remaining variable, because at that point you're going to take an equation that used to have both an x and a y, and you turn it into an equation that only has x's or only has y's. Okay, then you plug it in to the one of the original equations and solve. Okay, keep in the back of your head, remember that we're looking for a point where the lines intersect. So by the end of this, we need an x and a y to give us that ordered pair. So in order to use substitution, you have to have an x equals or a y equals already in one of the equations. Okay, so this says y equals 3x. So my first equation, I have y by itself. So that's what I need to use substitution. So this is what we say. We know y in the first equation because the first equation says y equals. So if we know y in the first equation, we replace the y in the second equation. Okay, we know y in the first, so we replace the y in the second. So I'm rewriting the second equation. So x plus 2, I am replacing that y with what I know y is. I know that y is 3x, so then that's what I'm plugging in here for the y. And then it still equals negative 21. So if I look at what I have now, it might look more complicated, but I took something that used to have an x and a y, which I can't solve, and I turned it into an equation that only has x's. So now I can solve it. So x plus 2 times 3x is 6x equals negative 21. The x's are on the same side, so I just smushed them together. X plus 6x is 7x. And then to get the x by itself, I'm dividing both sides by 7. So x equals negative 3. Okay, so I solved for x. Remember, we're looking for a point where the two lines intersect. That's not done yet because I only have an x, and I need an x and a y. So I'm going to plug that back into one of the original equations, and it doesn't matter which one I plug it into. However, it's going to be easiest to plug it into this first equation because the first equation already has y by itself, and I'm going to try to find y. So y equals 3, and now I'm substituting the x in with what I know x is, which is negative 3. So 3 times negative 3 is negative 9, and now I have an x and a y, which is what I need. So now I can write my ordered pair. My final answer is negative 3, negative 9, x and y. And there is the point where they intersect. Just to test it, let's see what we find. If we put this in Desmos, like we were doing yesterday, So if I have y equals 3x, and then x plus 2y equals negative 21, and then we look where they intersect at negative 3, negative 9, which is the point that I got. So you can always check yourself in Desmos because you're looking for where they intersect, but we're just going to use different methods to get there, and today we're going to use substitution. Alright, so in order to use substitution, you have to have an x equals or a y equals. We have that in the very front because we have x equals at the first equation. So we know x in the first equation, so we replace the x in the second. Okay, the first equation says x equals, so we know x in the first, so we replace the x in the second. So I'm replacing the x with what I know x is, which is 2y, and then finish out the rest of the equation. So plus 2y equals 15. And now we're solving. So 4 times 2y is 8y plus 2y equals 15. Again, these y's are on the same side, so just smush them together. That gives us 10y equals 15. Divide by 10. 15 is not evenly divisible by 10, so we're just going to simplify it, and they're both divisible by 5, so we're just going to get 3 over 2, or 1 1/2. Okay. Now, there's our y. We have to plug it back in to get x. It's going to be easiest to plug it into the first one because it already says x equals, and we're looking for x. So x equals 2, and we now know y is 3 over 2, or 1 1/2. And then 2 times 3/2 is 3. And now we can get our point where they intersect, and the x coordinate is 3, and the y coordinate is 3/2, and then that is where they intersect. And you can always check it in Desmos. Alright, this one we need to remember, in order to use substitution, you have to have an x equals or a y equals. This one actually, both of them say y equals, which is fine, there's nothing wrong with that, so it doesn't really matter. So we'll say we know y in the first, so we are going to replace the y in the second. Okay, so we know y in the first, we're going to replace the y in the second. Y is by itself, so I don't have to put parentheses, I'm just going to replace it with what I know y is up here, which is 3x minus 8. So instead of that second y, I'm going to write 3x minus 8 equals, and then this side stays the same, 4 minus x. I took something that had x's and y's, and now it just has x's. My x's this time are not on the same side, so I'm going to go ahead and add this x over. You have to do the opposite to move it. So 3x plus x is 4x, minus 8 equals 4. Continue to solve. So add the 8 to both sides. So 4x equals 12. Almost there. Divide by 4. So x equals 3. Okay, now that you know that, you're going to plug it back in. It's best to plug it in because you're looking for y into an equation that says y equals, which they both do, so really it doesn't matter. So you pick whichever one looks easiest. I think the second one looks easiest. So y equals 4 minus, I now know x is 3. 4 minus 3 is just 1, so y is 1. My final answer is an ordered pair, the point where they intersect. The x is 3, and the y is 1, and then there's our point. If you wanted to check it, put it in Desmos. Alright, in order to use substitution, you have to have an x equals or a y equals. Now we have the x in the second, because the second equation says x equals. If you know x in the second, you replace the x in the first. So I put a box around the x in the first because that's what's going to be replaced. So I'm going to rewrite it. So 2, I see an x, I stop, I put parentheses, and I plug in what I know x is. I know that x is 1 minus 4y, so that's what I'm plugging in. The rest of that top equation stays the same. So plus 7y equals 3. Now it's just a complex problem that I need to solve. So I have to start by distributing to get rid of parentheses. So 2 times 1 is 2. minus 2 times 4y is 8y. We still have a plus 7y equals 3. Your y's are on the same side, so you smush them together. This 2 drops down. That's a negative 8 plus 7. Negative 8 plus 7 is negative 1y equals 3. And then we just continue to solve. The 2 is positive, so to move it, you're going to subtract it. Leaves us with a negative 1y equals 1. You have to divide by a negative 1. And 1 divided by negative 1 is negative 1. So there's your y. We are not done because you also have to find x. And it's easiest to plug it into an equation that says x equals, which would be the second one. So I'm going to plug it in right here. So x equals 1 minus 4. Stop, put parentheses. We now know that y is negative 1, so that's what I plug in there. So x equals 1, and then that's a negative 4 times a negative 1, which is a positive 4, which gives us that x is 5. So the x is 5, and the y is negative 1, and we are done. It's a point where the lines intersect. All right, you can go ahead and do this one on your own. So on your own. And then you're going to do 7 too.